Hello guys, welcome back to my studio, and we are proceeding with our normal titration series. This one is now titration number 10, practical 10. So we are in my studio. I have a student here, and he can just be able to introduce himself, so that you can be able to know who is in my studio. So you can just tell the audience your names.
Hello guys, I'm Alan Godia from St. Teresa's Place.
Good. So now we are just going, it's just going to measure some solutions here using the measuring cylinder so that he can put them into the conical flask. And then he also has some pipettes. We also have the burette here, the burette that is having the solution. So we are just going to do some titration here. And before we go to the procedure, I just want us to go through at least the apparatus that we are using in our studio here. First of all, we have some two conical flasks here. You can see we have some two conical flasks here, and two conical flasks, they are here, and we have our respective solutions that are going to be we are going to use them in our practical. We have here sodium carbonate, which is 0.5 molar, and also we also have our hydrochloric acid here of unknown concentration. So according to the procedure here, we are just going to go through the procedure as per instructed first, so that you can be able to know what we are exactly doing. Before we do anything else, I will tell Alan, right? Alan, just to read the procedure here within the book, so that we can be able to know that what the kind of procedure that you are supposed to follow.
Okay. You are provided with an acid W in brackets HCl whose concentration is unknown. You are required to standardize it using standard sodium carbonate solution, which is 0.5 molar. Procedure: using a clean pipette exactly 25 centimeter cubic of the sodium carbonate solution into a clean 250 centimeter cubic conical flask. Add 2 to 3 drops of methyl orange indicator. Fill up the burette with acid W. Titrate acid W against sodium carbonate solution until the color of the indicator first changes to pink. Repeat the experiment to obtain 2 concordant titer. Record your results in the table below.
So in the table below, you can see that we have the final burette reading, and we also have the initial burette reading, all of them which are supposed to be in cubic centimeters, and then we have the volume of the solution N used, which is what? The acid, right?
Yes.
And then the questions that we are being asked here, we have been told A, to calculate the average volume of the acid solution N used. Then B, we have been told to calculate the number of moles of sodium carbonate used. Then calculate the moles of acid in the volume used. Then the number of moles of acid in the volume used. Then calculate the molarity of the acid, that is D. Then E, calculate the concentration of the acid in grams per liter. So that now, in this case, we are just going to do as per the procedure. Now, Alan is just going to he has taken 25 cubic centimeters here, and he's just going to, he has pipetted using a measuring cylinder, using a pipette, and then he's transferring them into a very clean conical flask. This is a conical flask. So we are just going to, he's going to add 2 to 3 drops of methyl orange indicator so that we can start the titration process. Let us just count the number of drops. 1, This is drop number 1. 2, 3. Good. Now, before he does that, we must also make sure that we have seen the volume, the initial burette reading, before we do anything else. And before we carry out any practical, you are supposed to make sure that you remove the funnel from the burette. Just remove the funnel. Good. So now from there, we are going to read the volume of the burette, the initial volume of the burette. As you can see there, the volume is exactly what? 0.0. Or is it slightly above? Is it slightly above? Let me see. It is somehow slightly above. It's supposed to be just reduce with the one drop only. Slightly. So that we can start at 0.0. Good. There. So as you can see, at the low mains gas, it is coinciding with the 0 mark of that solution in the burette. It is coinciding. So after we have done that, then he's just going to put the conical flask under the tap of the burette, at the low tip of the burette, so that we can continue titration. We can start with the titration process. Let us start. Just drop by drop. As you swine the burette, as you swine. As you can see now, the reaction has started in the conical flask. And in the process, as you know that sodium carbonate, when it reacts with the hydrochloric acid, the products are sodium chloride, carbon dioxide, and water, right? Water, which is a liquid, and carbon 4 oxide, which is a gas. As you can see the bubbles, that is carbon dioxide that is being produced in the conical flask, right? So now carbon dioxide is being produced, water is being also formed, and also sodium chloride is being produced on the product as the product. So we are just waiting for it. It has changed. So we have just found that the solution has changed to pink. As you can see, the solution has changed to pink, right? It is properly indicated. Is it pink? Right? Pink, right?
Yeah.
You can see yourself. You can see we have just got the very accurate results. So now we are supposed now to go to the burette, and then we take the final burette reading before we proceed. So we have found that. Let us just see the final burette reading. You can just use your hand because it is the one that it can be able to give us the contrasts. You can see the final burette reading. It is 19 point. Let me read towards this. Good. Let me read towards this direction. Read the burette. Oh, just put your hand there. As you can see, it is 19.2, right?
Yeah, 19.2.
19.2, right?
Yeah.
Around. Let me see. 19.2. Let me see. 19.2. Good. So we are going to record here in our table here. Let us just correct the first. Just correct this point. It's 19.2. Yes. 19.2. 19.2. So the initial burette reading, it was supposed to be. The initial burette reading was 0.0, and then the final burette reading is 19.2. So we are just going to record in our table here. The final burette reading, it is 19.2. The initial burette reading, it was 0.0. So our initial burette reading now, it's coming to be 19.2 in our next column. in our next titration. So let us just continue with the same, and we are going to record our results in the table after we have finished. So in the long run, as he continues to pipette, I'm just going to take you through the apparatus also. As we proceed, the apparatus that we have the filter funnel here. As you can see, the functions of the filter funnel, it is the one that is placed on the burette mouth or the burette brim, so that it can control the solution from splashing to outside, right? So it prevents the burette, the solution that is being poured into the burette from splashing to outside. So it makes sure that all the solution that is being directed to enter into the burette, it completely goes into the burette, right? So now we are just going to carry out another titration, whereby this is our solution, our second solution that is going. It has been pipetted. We have pipetted using this pipette. This pipette, it is graduated 25 mils. So it is specifically, it's supposed to carry 25 cubic centimeters of any given solution at 20 degrees Celsius. As you can see the indications here, you can see the writings that are on the burette. It is 25 cubic centimeters. So that 20 degrees Celsius, it is indicated there to make sure that the solution that is inside the pipette, it is 20 degrees Celsius. So let's continue the second titration. So let's put our indicator inside the conical flask. One, two, three. So we are just following that procedure that we have gone through initially. So let us just put the conical flask at the bottom of the burette, and then we continue to titrate. Since we know that the solution will change at around 38, 39 there, you are not supposed to waste a lot of time. You are just supposed to release the solution until up to around 20, 30, 34, 35 there, or 36, 37. That's when you can slow down that's when you can be able to be keen in as far as hydrochloric acid that is coming from the burette is concerned. So let us see what we are going to get after we have titrated the endpoint results. You see, carbon 4 oxide is the one that is producing the bubbles in the conical flask because of the products that we have mentioned in the first titration. Let us see. And the products are sodium chloride, carbon 4 oxide, and water. Slow down and make sure that you be keen when you are titrating, so that when the endpoint is reached, the endpoint mark is reached, you just stop the titration process. Let us see how the solution is going to change. It is just almost to change. Almost to change. Wow, almost. Just slow down. Drop by drop now. Drop by drop. Drop. Wow, it has almost. Just a drop. It has changed. Good. Now you can see the results are very clear. The solution has changed to pink. You can see. the results are very, very clear and very, very bright. So now after we have reached the end point, then we are also supposed to go back to our burette, and then we make the final burette reading here. So we just come here and see the final burette reading. Let me see. 38.8. 38 flat.
0.1.
38.1.
No, 38 flat. 38 flat.
38.0.
Yeah, 38.0.
So we have gotten 38.0. Let me just make it clear. 38.0. As you can see, it is 38.0. So we are going to record in our table the final burette reading in our second column. 38.0. Good. Oh, you are not supposed to indicate the cubic centimeters in the table. So, in as far as recording in the table is concerned, you are not supposed to indicate the units inside the table. So, but you just make sure that you maintain one decimal point, right? One decimal point. If you are supposed to follow the laws of titration in the table, make sure that you maintain the 1 decimal point while recording the results. Or if you have decided to use 2 decimal points, just maintain 2 decimal points. In this case, we have decided now to use 1 decimal point. So we have obtained 38.0. So that is our final burette reading. So this 38.0, we are going to subtract 19.2, as you can see there. Then it is going to give us something to do with. So we shall just do the subtraction later. Let us refill the burette. We can just fill the burette up to a certain point, as long as we can be able to get the 19 units. Yeah. At least 19 units.
We use the funnel to
splashing. So we just use the filter funnel so that we avoid the solution from splashing to the sides, right?
Yes.
Or to outside, right? Yeah. So we are just putting the hydrochloric acid inside. Is that an hydrochloric acid, right?
Yes, this one is concentrated.
Hydrochloric acid, right? Yeah. Okay. So now, our initial burette reading when we shall be doing the third titration. Are you deciding just to put it to the 0.0?
Should we
okay, you can just choose it whatsoever the volume that you might use. But it is not a must that you utilize 0.0. Okay. In this case, our initial burette reading, we have decided to use 0. We have decided our initial burette reading here. In this case, it is, as I can see, it is 7 point what? It is 7.1, 2, 3, 7.7. Let me see at the low main scars. 1, don't shake your hand. 1, 2. So 7.7, 8, 9, 10. 7.7. So our initial burette reading here, it is 7.7. So we are just going to record in our table the initial burette reading here, it is 7.